these spans, if they're equal, we have that nice line. If they're too small, they kind of flap here, and you see the red bus right in the water. And then if they are bigger, if they add up to more than this side, you get a triangle. So, can we do this? We can do this. I'm going to give you a paper, and I've got some protractors. You're going to measure sides and do it in millimeters, and you're going to measure angles then. Can we notice anything about our smallest to biggest sides and our smallest to biggest angles? Is there anything we can see? Yeah?
The bigger side has a small angle.
Well, let's see. The biggest side, which was which one? This one. Has the smallest angles adjacent to it. Okay. Where is the biggest angle? Opposite. Now, what's an opposite angle? When you have a triangle, if you have an angle, the opposite side is over here, right? So an angle and its opposite side are here, or a side and an opposite angle are, that's how we describe it. So where would the opposite side to this angle be? Bottom, right here. Where would the opposite side to this angle be? Right, kind of across from it. So not adjacent. So let's see if we can make a conclusion, or at least an inductive observation, that the smallest angle is opposite the smallest side. The medium angle is opposite the medium side, and the biggest angle is opposite the biggest side. Now let's think about that. Does that make sense at all? Now what does an angle do? It opens up openings. So does it make sense that a big angle would have a bigger opening? It's nice when it makes sense. If you really think about it, I think that kind of makes sense. Let's see what else we have to say about it. Okay, so we do have some theorems. If one side of a triangle is longer than another side, then the angle opposite, the longer side, is larger than the angle opposite, the shorter side. See, these always sound so complicated. But basically, it's what's saying, if you have a long side here, and it's longer than this side, it must be that we opened up that angle bigger than we opened up this angle. That's the only way you can get a bigger side. You're opening the angle bigger. If one angle of a triangle is larger than another, so now we're looking at the angles. I've got two angles here. Then the side opposite the larger angle is longer than the side opposite the smaller. So I've got two opposite sides here. I've got AB and I've got BC. So which one of these is going to be bigger than the other? Not by looks, but by other evidence. Yeah. Why is BC is what? Bigger than that one? BC bigger than this one. Why? Its opposite angle is bigger. This one opened up bigger than this one. So you're going to get a smaller side opposite that one than this one. That makes sense. You kind of see that? Okay, is there a little trouble? Because that's right now, right? Just think about, the door opens, you get a wider opening versus a smaller opening. We don't need to explain that at all. Okay, so here's an example. First of all, what's the measure of angle A? Put this one away. We're back on the notes here. What's the measure of angle A? I'm trying to see if I have this on there. Go. What do we get? What do we get? How do you get 36 degrees? Is that right? I didn't even check it. That sounds about right. Okay, so this is 36 degrees. So I know off the angle measures. What's the longest side in this triangle? Maria? AC. How come? Yeah, here's my biggest angle. So this has to be the biggest side, the longest side. What's the shortest side? What's the shortest side, Jake? BC. Okay, why? Well, you have to look at angles. So let's look at angles. To be the shortest side, the opposite angle, how far is it opening? Well, you're right. That's the smallest opening. It has to be this is the smallest angle, so the opposite has to be the smallest side, because it's just not opening as far as the other one. And that makes it, I hope that's making a little sense. And sometimes it's a little hard to find the opposite side, so just kind of look above it. What's the middle length? What is kind of the medium? Not the biggest, not the smallest. Yeah? BC because why? It's the middle side angle. All right, so does that make sense? And so now if I want to write the inequalities that describe the order of the lengths, well, let's see, from smallest to biggest, say, so what's my smallest side length? So the 36 is, the 29, so I'm going to go AB, right? Is going to be smaller than BC? Is going to be smaller than AC? It makes sense at all, right? So smaller angles don't open as wide as bigger angles, so the side opposite them are going to be smaller. Note that we can only determine order by angle measures, but I don't know the lengths of the sides. I only know relative lengths, one bigger than the other or smaller than the other. Okay, so you try these. I want you to look at the sides of angles. So if I'm giving you a side, give me the angles in order. If I'm giving you angles, then give me the sides in order. Okay, give that a try. Okay, let's talk about this. How do we do with A? I got angle E is less than angle D is less than angle F. Yeah, I got a thumbs up. Questions on that? For this one, AB less than AC less than BC. I'm getting more thumbs up. Ask the question if you haven't. How about this last one? Did you have trouble with this one? I got angle 2 less than angle 1 less than angle 3. Right? Because X would have to be the smallest. This one has to be the middle side because you're adding 2, and this is bigger because you're adding 4. And X has to be, because it's a side length, it can't be 0. It has to be bigger than 0. Yeah? Well, we're going smallest to biggest, right? So where's my smallest side? Here, right? So you look across. This would have to be the smallest angle. Where's my medium side? Well, that's this one, right? So you look across. That has to be the next one. Then you look at your longest side. Well, that's this one. Then look across. That has to be your biggest angle. Okay, so it's always you're looking opposite. Looking opposite. Okay, excellent. All right. Oh, I don't know if I want to do this investigation. This one, I used to teach this after we learned about constructions, which you guys aren't going to learn about constructions for a while. You know, for fun, I'm going to turn off the recording. So this is not recorded for posterity. I'll tell you why. Because I have to use tools, and I am very not good at using the tools. Here's a protractor. Do I need a protractor? Yeah, I guess I do. Actually, I don't. I'll get rid of that. I just need a straight edge. Tools. I need a straight edge. And I need a compass. Oh, what? A compass. And you know, you have to believe me, I'm awesome with a compass, but it's a real compass. Yeah, it's a thing like this. I'm unstoppable. When it's a tool like this, oh, I struggle with it. Basically, all we're doing here is we're building the triangles. I'm just going to shut this thing. So what I did was, for this example, I made my one side. It goes up through here. So this, you know, doesn't belong anymore. I found the length of this arc. So somewhere along this line would be where I'm going to draw that third side of my triangle. And then this is the length. Everything along here is going to have that same length. It is like a circle. Like these are different radii, all of which are going to be the same length as this other line. If I can figure out how to move that thing. But what happened to my triangle? Like if I were to make any lines on here, what's going to happen? What happens to my triangle? What? It can't close. Why not? The bridge isn't long enough. This is the Tower Bridge problem all over again. So with Tower Bridge, if I don't make them long enough, that's when the big red bus would fall in the drink here. So let's go back to that kind of rule we discovered. Here are these things. Does that make me nervous? What's the rule then? So to have a triangle, let's say this is my biggest side. What must be true of the two shorter sides? Equal. Now it's equal. Equal is Tower Bridge. But I want a triangle. So is equal good? Has to be bigger. The sum of these two lengths has to be bigger. And that is the rule here. The sum of the lengths of any two sides of a triangle is what did I say here? Greater than the side of the third. So I use my little building rods here to kind of show that you can only do that when the sides are the same. So AB, so if you look at a third side, here's AC. This plus that has to be bigger than AC's length. If you're looking at AB, this side plus this side has to be bigger than AB. And if you're looking at BC, those two sides have to add up bigger. Okay? So that's my rule. So is it possible to have a triangle with lengths 5, 6, and 12? Is that possible? What? Well, is it? You tell me. We have the information we need. The two sides have to add up to more than the third. So I'm looking at what's 5 plus 6?
No, 11.
Is that bigger than 12?
No.
It's less than 12. Not a triangle. I found two sides that don't work. Let's see. How about this one? A triangle has one side of length 12 and another of length 8, like this. Find the possible values of x if the length of this for the length of the third side of the triangle. So let's say x is over here. X plus 8 has to be bigger than 12, right? Doesn't it? Because this plus this has to be bigger than that. So that makes x bigger than 4. What else do I know? Here is x. What if these are the two other sides? 12 plus 8 has to be bigger than x. So it has to be bigger than 20. So I've got two possibilities. X bigger than 4 or x bigger than, less than 20. Now we can write what's called a compound inequality statement. Compound inequalities always go with less than, because I'm trying to put x between two numbers. So read this. X is less than 20. X is bigger than 4. This is a way of saying the value of that third side is between 4 and 20. Yeah. I could? I can't. If this is 3, adds up to 11. Yeah, but I have to work on both, right? I have to work on both because that's my triangle. It's just which way you're looking at it, right? It depends which way you're looking at it. Now here's like a trick that makes this really easy. See 8 and 12? Right, those are my two sides. 12 minus 8 is 4. 12 plus 8 is 20. And voila. So you basically subtract, you add, and those are your boundaries. And that's it. That's not so bad. So is it possible, let's just look at this one, because that's that example here. What would the two lengths be? What would x be between 3, 4? What are the possible sides of the third? Subtract, what do you get? Add. There you go. All right, so try these. You try to determine, here's 3 sides. Give me 3 sides. Can they make a triangle? And this one is, I'm giving you 2. What's the range of sizes for the third one? All right, what is the Hinge theorem? These theorems are just so crazy complicated the way they're written that I think it's easier just kind of talking them out. I like to think of a hinge on a door. We're looking at the door. You know that's what the hinge is, right? If you open the door wide, how big is the opening compared to if you open the door a little? Right? It's going to be bigger if you open the door a lot, and it's going to be smaller if you open the door a little. That is basically the Hinge theorem. Now the Hinge theorem bounds an angle between two congruent pieces, and by corresponding part congruent. So here's 2 triangles. See how this is congruent to that, this one's congruent to that one? So if you have that situation, you can look at the included angle there. Who's going to have the bigger side? The one with an 88 degree or the one with a 35 degree? Who's opening their door wider? Yeah, so this just says, well, an XW must be bigger than ST because I opened the door wider. But it is important that we have this congruent situation because the length of a side can affect, if this was much longer, that would affect that third side length. Same thing now, if the door is open wider than at another time, what's the angle going to look like? And again, the same condition where we see some congruence there, corresponding congruence. Look at the included angle. You open the door and it's 12 feet big. You open the door and it's 9 feet big. Which angle is bigger? Which one? Angle C. And if you think about just opening a door, I think it makes more sense. I think these words, it's like a whole story. What? It's more common sense than that. Open the door. Are you going to get a longer side or a smaller side? So when I look at some of these examples here, oh, look at that thing. Come on the back. That is so complicated looking, but let's just sound it out. And these are, I think supposed to be the lines for you, Rachel. Actually, no, because we're looking at the measures. I'll take that back. I'm right this time. All right, so we look at AC, and we look at EG. And we want to know, are those two things equal? Is one less than the other? Is one bigger than the other? Well, look at my angle. And I'm looking at sides, 14, 14, 16, 16. I'm in the situation where the corresponding sides are congruent. The included angle, I opened the door the same for both. So what do I have here? Wait, is it less than, greater than, or equal? It has to be equal. Because I opened the door the same. Now, if I'm looking at A, B, and F, G, where's it going? Oh, I changed the color. Okay, A, B to F, G. Am I in a Hinge Theorem situation? 16, okay, so the sides are the same. I'm going to look at my angles now. Who opened the door wider? Yeah, so FG is bigger, but wait, how is it phrased? AB. So AB and FG. So AB, is it bigger than, equal to, or smaller than FG? Smaller, right? Less than. Does that make sense? That's what we're doing here. Let's see what it's got here. It's BE. BE is 12. And what else I got? EG is 8. What do I know about angle BDE and EDG? All right, less than, greater than, equal. Am I in a Hinge situation? 16, 16 to 14 works for both, right? So who opened the door wider? Do you know? Well, what's the measure of D? What? What? Yeah, which angle? So, yeah, this one has to be bigger, doesn't it? Because the door was opened wider than that one. If EG equals 8 and CF equals 8, what am I trying to find here? CDF. 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 And which one? EDG. This one. Am I in a Hinge situation? 14, 16, 14, 16. What's going on with that one? Right? 8 and 8. Did I open the door the same? So what do I know about the angles? They have to be equal. So see how that kind of works? So there are some new tries here I would like you to do, where you're basically doing that. You're looking, am I in a Hinge Theorem situation? So you need the corresponding congruence, and then see how the door is open. Are we opening the door wider, or maybe we're opening them